first of all, good afternoon, everyone. Again, my name is Eric Gubi. I'm a Senior Solutions Engineer at VMware. I'm part of the Modern Applications Business Unit handling Southeast Asia. So just a disclaimer, this talk is non-technical. It's basically just strategies and basically just the why are we doing this transformations, cloud native technologies, and basically the app modernization initiatives from different companies. So basically, it's all about today's landscape, right? We always talk about digital transformations, cloud native technologies, containers, but there's always going to be this big word, application modernization. So for this talk, I'd like to discuss what this is, how it's done, and more importantly, the why we need to start looking at it from a business perspective. So digital transformations, right? So basically what's happening right now, digital technologies are changing the way we do business today. Everything is connected, mobile, social networks, wearable devices, connected cars. They are influencing the way we behave and engage with technologies today. So basically, when was the last time you went out to grab a taxi or go physically to a store to pay bills? In today's world, these services are basically all phone click away. So as a result, customers are demanding more innovative, flexible, and faster way to experience products and services. This creates a demand for exceptional user experience and maintaining it across all channels. This becomes a baseline necessity for today's ultra-competitive market. And this change is accelerating faster than the pace of transformations in organizations. This is why digital transformation is on the radar of many organizations. In today's mobile-first, cloud-driven world, technology and your business and an ability to embrace digital transformation will make a big difference on how you stack up against the competition. It's important to note that simply spending more on emerging technologies does not equate to a successful digital transformation strategy. For that to happen, these investments need to boost business outcomes. If you look back years before, a product-focused outcome has shifted our experience to experience-based ones. Basically, at the start of 2010, you can see a shift less on a revenue per product, but more of a direct interaction with customers. Digital transformation is driving customer experiences. To put it simply, enterprises are looking to modernize because they recognize there's a huge opportunity in these three areas. First would be build seamless customer experience around solutions, services, which in turn opens up opportunities for creating additional revenue. Now, as you keep solutions and services connected, managing these growing services will be in the next step. This is the second reason why enterprises are modernizing. Enterprises need to find a way to ensure security is at the heart of its innovations. And last, as cloud technologies are advancing, enterprises are looking for ways to take advantage of these innovations to bolster their own capabilities in providing value to their business. And it's happening everywhere. According to Gartner, by 2025, more than 85% of global organizations will be running containerized applications. And at the same year, IDC also predicted that nearly 2/3 of enterprises will be prolific software producers, with daily deployments having 1.6 times more developers than today. With all this said and done, two questions are always asked, or we always hear from our customers. How do we move toward modern apps with greater velocity? How do we operate modern infrastructures with more stability and at scale? But before we go understanding how to operate a modern application, we need to define first, what is a modern application? Since application is a fairly generic term, let's define what we mean. A modern app is basically a resilient multi-cloud software service comprised of orchestrated releases of containers, virtual machines, and serverless functions. This definition is a bit of a synthesis of some of the technologies you guys have already encountered. If you break it down closely, the definition of an application has changed. An application used to consist of virtual machines we treat as pets. And like pets, we normally name them like Web Server 01, App Server 01. We take care of them by making sure we continually patch them, upgrade them. Same maintenance routine we do to our pets. we do the same thing to our applications or virtual machines. And when they die, this is what we call in IT a save one ticket, wherein we scramble to revive our loving pet. In today's velocity of change, allocating bandwidth in doing all of this is counterproductive as you end up late in the curve of innovation. Now in modern apps, this is not the case. A modern app consists of different types of systems for virtual machines, containers, to serverless functions, or maybe applications leveraging a virtual GPU. They are all loosely coupled and are treated as cattle. Cattle, unlike pets, are disposable. They function as one of the herd, meaning as long as they serve the intended purpose, you are good to go. In case of failure, cattle can easily be replaced by a member of the herd without impacting the overall service it provides. The metaphor of one trusted companion, a pet for this case, versus a hardworking cattle, help define one of the biggest paradigm shifts in cloud computing. Comparing what is this then and now, then we assume a reliable infrastructure. Basically, we release code every 3 months with siloed responsibilities between developers and IT. Components are all tightly coupled. Now, in the cloud computing age, we assume a fragile infrastructure. Things will eventually fail, and as such, services and components are designed to be loosely coupled because of the loosely coupled nature, code can easily be released independently. Now, when we talk about apps, what does it comprise of? An app comprises of three bodies of code. A feature code, which basically provides features, updates, and bug fixes to business services. The objective is to create a new experience to our customers, which eventually lead to increased revenue to the business. Infrastructure code deals with IaaS, PaaS, or CaaS, basically anything X as a service. It also contains definitions on how we put governance, security to our infrastructure. The overall goal is to reduce the time to market for the developers. It paves the way from code to production, seamless, and at the same time, conforms to the governance and security construct the business requires. Lastly, reliability code. They are created to provide observability from infrastructure up to the application logic, providing valuable informations and correlations to predict both external and internal change. This allows for predictive and reactive scaling for both the infra and application level, which in turn provides a reduced operational expense for the business. When it's all said and done, these code are all deployed in what we call an application platform. Application platform is a set of services that provide efficient development, deployment, and sustainability of software. We consist of app code, development tools and frameworks, runtime platforms or application data platforms, sustainability and enabling services. Now going back, right? Why are we all doing this? Summarizing modern application platform, the heart of the question will always be, why are we all doing this? To put it simply, we seek close relationship with our customers. There's a famous model by author Simon Sinek called the Golden Circle. In a nutshell, it says to be able to connect to people, you should always start with the why. As it embodies the purpose, cost, or belief, it's the very reason your organization exists. In the case of modern application, the why is because we bring everything together to appear as one, that you can realize more fruitful relationships with your customers. How we do that is by uncoupling the tightly bound, watching everything happening, and presenting it all in a right way and at the right place. So interactions are seamless. What? Well, we're just basically creating modern applications. To have a practical example, let's use a sample industry. In this case, a wine industry. So for this particular industry, we have three actors in business. A maker, which basically creates the actual wine producers. They harvest and then put everything in the barrel for it to ferment. Then we have a tasters. A tasters is basically qualifies what we produce by the makers. It actually tastes the wine ready to be enjoyed by the next persona, which are the enjoyers. They are basically the wine lovers in this case. The goal of modern apps should be to maximize relationship between providers and consumers. The bullseye for a winery is making it incredibly easy to pick and extract right wine for the price of each customer specifically. Relating back to the golden circle, as we move closer to the center, we reach the why, which is at the center of the circle. It creates a connection with the customer by customizing their preference both on the tastes and the price with what we can offer. In the old world, or traditionally, after making a wine, what happens is the sommeliers or tastes the wine and rate it. They would be the one rating on what kind of wine is produced by the winery. And at the same time, the users would now start consuming those. There's really no way for the winery to incorporate the feedback from their customers directly into their rating and inventory placement. That form of continuous customer engagement requires a more digitally transformed enterprise. To summarize, the flow is basically from left to right. It's all one way. Now, on a modern app-based operation, we may choose to insert machine learning to rate wines instead of humans, and at least with experts paid by experts. What happens is we put sensors at the wineries, and then from that particular sensors, all the data gets fed on an AI platform. The AI platform would then dictate or basically predict what kind of wine would be produced. And at the same time, the sommeliers would also help rate this as part of a batch. All the customer ratings and how the customers are buying the wine are also get fed on the AI platform, together with the data from the winery, and at the same time, feedback from the customers. You can able to predict what's best or basically what's good in this particular season or what's needed by the customers. If you look closely at the data flow, a modern application brings everything together. In order to promote better relationship with the customers and users alike, data scientists build the training sets for the machine learning. And as the training sets updated in the object stores, what happens is data scientists train these metric sets to be able to understand how the sensors from the winery gets influenced and also gets the feedback from the customers from their ratings and how they buy, and also trains that particular data to be able to present to the users on how the wines should be consumed. What happens on a modern app would be data flows from a winery to a big data stores that are ingested to, in this case, in a Kubernetes clusters, then get fed on a TensorFlow or machine learning training sets. These training sets are then fed back to the wineries as part of the platform, and at the same time, the continuous integrations from wineries to the microservices are being done. A detailed look at the infrastructure would look like this. Basically, we have a physical host that are all running on vSphere, a compute clusters that are hosting Kubernetes clusters that are all being run by different kind of services that would feed or basically run all our modern applications. If you put into our binary modern apps into a golden circle, the why for our app is to bring everything together to appear as one winery so our consumers can enjoy a more easygoing, fruitful relationships with us. How do we do that? By uncoupling our old, tightly bound interaction model. We watch everything happening, presenting it all in the right way to our experts, and finding the perfect wine an instant and easy. What is it? You just happen to make a great apps to deliver your wine. Now, on the last part, how do we actually do it? In a nutshell, we uncouple, watch, and provide the right info. What do we mean by this? So from the core, each part of the supply chain plays an integral part of the business in building modern applications. We should build relationships with each of our customers, not just external, but also internally. As part of our supply chain, you should treat your output as a product, not a project. And as you deliver these products, you start to get insights about your customers, again, from both internal and external, which will help you plan what the future state architecture would look like. In addition to this, we also need to get feedback on how our applications in all its parts are operating as one. Metrics consumptions is an integral part of this process. We need to ensure all our metrics logs are consolidated from different sources, from infrastructure to the platform and up to application logic. By doing this, we allow feedback on our applications are performing at the same time to introduce improvements as we operate. Closing on the topic, what is it and what do we need? Basically, modern applications require modern platforms to operate. It all starts with an idea. The code is developed to realize and address this idea. It goes through a build and test to ensure what we've done to address this original idea we envision and at the same time conforms to our business process and standards. It then gets delivered to an environment, depending on your company, can be staging, SIT, UAT, for testing by another broader team or automated tests. Eventually, this gets accepted and deployed to production. Maintenance is unavoided as it may include vulnerability patches, hotfix on the applications or on the underlying infrastructure. Using the metrics from all the data points, infrastructure, platform, application performance, we create a meaningful observability points which help us learn how our platform is performing in terms of both platform, application, perspective. This creates feedback for additional idea or improvement, which triggers the whole cycle again, iterating from feature code, infrastructure code, and reliability code. The whole idea is to ship code faster at lower costs with no outages. If we break it down further and zoom in to each steps, it can be summarized to the following actions. The code, we need to prepare resources, develop applications, secure access at the same time, follow company policies. On the build portion, we need to start compiling components, test application, at the same time bind catalog services. These catalog services can either be outsourced from the open source or can be built in-house. The deliver portion contains create images, store images, validate images, basically all operations that are required for a containerized application. On the deploy part, this is where we deploy applications, provision services for those applications, and at the same time discover any auxiliary services that are required for your applications to run. At the same time, you need to have specific routing traffic. How do you expose these particular services for the customers to consume? On the maintain part, this is where we resolve issues. Scale applications. How do we do zero-time upgrades or zero upgrade runtimes? Upgrade OS, upgrade platforms, backup data, restore data, and manage access. In the observe portion, this is where we aggregate logs, aggregate metrics, trace issues, prevent issues. And then on the learn portion, how do we do canary deployment or A/B deployment? With VMware Tanzu, we basically help address all these areas with solutions to meet enterprise needs. Tanzu Kubernetes Grid is our Kubernetes runtime certified to run on any cloud providers, whether vSphere or any public cloud you have already invested in. The aim of Tanzu Kubernetes Grid is to provide seamless or basically the same Kubernetes experience regardless of which cloud, whether it's on-premise or any public cloud that you guys are already using. Tanzu Mission Control is our central control plane to manage disparate Kubernetes clusters located in any locations. It can manage both Tanzu Kubernetes clusters, also any Kubernetes conformant distributions. By having this control plane, IT operators will have a single experience in managing and pushing policies into different Kubernetes clusters. Basically, Tanzu Mission controls helps IT personnel to have consistent operations of Kubernetes clusters, regardless where they are, even if it's not Tanzu Kubernetes clusters. Tanzu Build Service, it basically automates the creation of containers. So no need for your developers to mess around creating Docker files, making them focus on what matters, creating code, and providing value to the business. With Tanzu Build Service, what happens is we're the ones managing the creation of containers. The developers will just have to push the code to that particular service, and the containers will be handled by the Tanzu Build Service. All the patches, all the required vulnerability fixes would all be incorporated as part of the build service. Tanzu Application Catalog ensures whatever we consume as part of the auxiliary services in our application is properly audited and have complete provenance on how they were built. Basically, for developers that wanting to consume services, for example, RabbitMQ, MySQL, instead of sourcing it from the open source community, Tanzu Application Catalog provides an audited view provided by VMware to make sure that what you guys are consuming are properly patched and secure, and the history of those particular applications are properly audited. Next, Tanzu Observability provides the visibility we need to correlate all the data that is happening, starting from the infrastructure layer up to the application metrics. It creates the necessary correlation and provide feedbacks for improvements in all layers of our modern platform. Tanzu Service Mesh allows us to create global namespaces, which facilitates in connection of applications from different Kubernetes clusters. This abstracts the underlying Kubernetes infrastructure for our developers to ensure their applications just run regardless of where they are or where their components are located. Basically, it provides them, abstracts the Kubernetes clusters so that developers can just deploy their applications regardless where the Kubernetes clusters are. Spring Framework or Spring Runtime is created by Pivotal, which is now part of VMware. It's the most popular Java framework. We started it and we can help your developers make the most out of it. Lastly, Tanzu Open Source. We've been contributing to the community to help bring common capabilities by having it open source to name a few. Tanzu Community Edition, our open source Kubernetes runtime, Harbor Registry, our open source image registry, and Carvel tools to help developers simplify their common tasks. Just focusing on the Tanzu Community Edition. VMware Tanzu Community Edition is a freely available Kubernetes platform for learners and users. With Tanzu Community Edition, you can experience VMware Tanzu right now. It's the same open source software that is used in Tanzu commercial editions, but it's freely available. You can install it, configure it in minutes. You can run it in your local workstations or favorite cloud. This is my last slide. The presentation with a quote from William Gibson that reads, "The future is ready here, just not evenly distributed. When placed in the context of application modernization, the agency that support and facilitates the adoption of this is already here. It's just with us that is left to start embracing it." Thank you.